Then we have grid computing. It involves connecting the remote computers geographically into a network of networks to create virtual supercomputer, okay, by combining the computational power of all computers present in the grid. Then we have computer networks and client or server computing. Here, the communications network links multiple computers for processing in a distributed environment where each machine has its own processing capabilities, okay? So the more widely used form of distributed processing is client-server computing. Then client-server technology splits the processing between client and server. And the client here is the user point of entry for the required function and is normally a desktop or a laptop computer, okay? Then the user generally interacts directly only with client portion of the application, okay? And the server provides the client with services. Okay. Then we have hardware and software, okay? Hardware consists of all the machinery and equipment in a computer, right? Okay. And then it's also the hardware consists of the following components like keyboard. A keyboard is an input device that converts letters, numbers, and other characters into electrical signals, which are readable by the processor. Then we have a mouse. A mouse is a non-keyboard, we can say an input device or a pointing device that is used to manipulate objects viewed on the computer display, right? Then we have a CPU, also known as the system unit, the case or system cabinet. It houses the processor chip, that is a CPU, the memory chips, and the motherboard with power supply, as well as also some secondary storage devices, okay? Then there is a power supply unit, which provides the power required for the computer to operate. And there is a fan. It's a part of the system to keep the circuitry from overheating. Then we have a screen. The monitor is the display device that takes the electrical signals from the video card and forms an image using points of colored light on the screen. Then we have a processor chip or a CPU for central processing unit. It's a tiny piece of silicon that contains millions of miniature electronic circuits, okay? Then we have memory chips. Memory chips is also known as RAM chips. They represent primary storage or temporary storage, and they hold data before processing the information and after processing, and also before it is sent along to an output or storage device. Then we have a motherboard. It's also called as the system board. The motherboard is the main circuit board in the computer, and the motherboard has expansion slots for expanding the PC's capabilities, which give you places to plug in additional circuit boards, such as those for video, sound, and communications. Then we have a video card. A video card converts the processor's output information into a video signal that can be sent through a cable to the monitor. Okay, then we have a sound card. A sound card enhances the computer's sound generating capabilities by allowing sound to be output through speakers. Then you have a printer. The printer is an output device that produces text and graphics on paper. Okay. Then talking about storage, input and output technology. In addition to hardware for processing data, we also need technologies for data storage, input and output, okay? So these devices are called as peripheral devices because they're outside of the main computer system, okay? Then we have something called as secondary storage technology, okay? And we have floppy disk drive. It's a storage device that stores data on removable, 3.5-inch diameter diskettes. Then we have a hard disk drive, which is a storage device that stores billions of characters of data on a non-removable disk platter. Then we have a magnetic disk. Magnetic disk is the most widely used storage medium. Then there are optical disks, which are, they use laser technologies to store large quantities of data, including sounds and images, in a highly compact form. Then we have a magnetic tape, which is relatively an older technology, And still some companies use magnetic tape, okay? And it stores data sequentially and is relatively slow compared to the speed of other type of tapes. Then we have a CD or a compact disc drive. It's more a recent variant. And there is a DVD, that is digital video disc drive. It's a storage device that uses laser technology, right? Then there is storage networking. There's large firm use network-based storage technologies to deal with the complexity and cost of mushrooming storage requirement, right? So input and output devices, as we can say that human beings interact with computer system largely through input and output devices, right? So input devices gather data and convert them into electronic form for use by the computer, and the output devices display data after they have been processed. Then there are some contemporary hardware tools, okay? See, the exploding computational power or computer hardware and networking technology has changed how businesses are organized in the contemporary age. So there is this emerging mobile digital platform, right? So mobile digital computing platforms have emerged as alternatives to PCs and larger computers these days. And communication devices such as cell phones and smartphones are used to perform many functions, including the transmission of data or surfing the internet, transmission of email and instant messages, and also displaying digital content and exchange of business data. Then there is nanotechnology. It is used to create computer chips and other electronic gadgets that are smaller in size than existing technologies. Then there is cloud computing. It's a new computing paradigm in which firms and individuals obtain computing resources and software applications over the internet on a paid basis. And cloud computing consists of 3 different types of services. That's cloud infrastructure as a service, where customers use processing, storage, networking, and other computing resources from cloud service providers to run their information system. Then there is cloud platform as a service, where customers use infrastructural and programming tools hosted by the service provider to develop their own applications. Then there is cloud software as a service. Okay. Then there is multi-core processors, where integrated circuits with one or more processors perform multiple tasks. Okay. So this was all about hardware. Okay. Then coming to software, what is the software? Software is a collection of computer programs and related data that provide electronic instructions. It tells a computer what to perform and how it should perform. So software refers to one or more computer programs and data held in the storage of the computer for some purposes. So in other words, software is a set of programs, procedures, algorithms, and its documentation. So program software performs the function of the program. It implements either by directly providing instruction to the computer hardware, or also by sometimes serving as input to another piece of software. So in contrast to hardware, we can say that software is intangible, meaning it cannot be touched, right? Something which cannot be physically touched. Then we have operating system software. It is basically system software that manages and controls the computer's activities, and it controls the hardware. It also manages basic input and output operations. It keeps tracks of your files saved on the disk and in memory always. And also, it also directs communication between the CPU and other pieces of hardware, okay? And it also coordinates how other programs work with the hardware and with each other. And then there are operating systems. They also provide the user interface. See, when the computer is turned on, the operating system is loaded into the computer's RAM, and no other program can work until the operating system is booted, right? Then we have computer language translators. What they do is they convert the programming languages into computer readable machine language. Then there are utility programs which performs common processing tasks such as printing, computations, then copying, sorting, and it also handles some system interrupts like technical issues. Then we have application software. See, business-driven software application tools, they are available to accomplish the business needs, right? So they are developed through traditional programming, and they are object-oriented programming, and they are also 4th generation languages. That means It is an integrated enterprise application. Then we have internet software. See, software tools to build websites and applications that run to fulfill the business's requirements on the web. We have Java, .NET, and Ajax. These are some of the examples which are used for building applications that run on the web. And there is HTML also, which is used for creating web pages. Okay. Then we have web services. Web services refer to a set of loosely coupled software components that exchange information with each other using universal web communication standards and languages. Okay. And then the example of computer software includes the application software includes end user applications of computers such as word processors or video games. Okay. Then there are middleware controls which coordinates distributed systems. Okay. Then there are some contemporary software tools. Okay, sources are now available, they are now inbuilt and are available for users for obtaining software and also capabilities to create their own customized software applications. Okay, then there is something called as open source software. Okay, it is developed by a community of programmers around the world. So they make the programs available to users under license schemes. That means you need to purchase the license. Okay. Then we have a term called information processing cycle. The information processing cycle is deployed in different forms on any given day. Okay. So there are some components of information processing cycle like input. See, input is whatever is put into a computer system. Input can be nearly any kind of data like letters, numbers, symbols, shapes, colors, or we can have this temperatures, sounds, pressures, even light beams, or whatever raw material that needs processing. Okay. Then when you type some words or numbers on a keyboard, those words are considered input data. Then there are some typical input devices like keyboards, mouse, scanners. Then there is barcode readers, microphone. Then there are joysticks. There's still camera and video camera. All these are the typical input devices. Okay. Then another component is processing. You see, it is the manipulation a computer does to transform data into information, right? So when the computer adds two numbers and the answer generated is act of processing. Okay, whatever the computer generates is the processing of the data. So the processing is done by the central processing unit or the CPU device, which consists of electronic circuitry that executes instructions to process data. Okay, so whenever the instruction is given to the computer, then the CPU processes the data. And there is another component called storage operation. The storage or mass storage refers to various techniques and devices for storing large amounts of data. Okay, so storage is of two types: temporary storage and permanent storage. Okay, permanent storage can also be called as primary storage. So primary storage or permanent storage, it is the internal computer's circuitry that temporarily holds data waiting to be processed. Okay. Then secondary refers to the devices and media that store data or information permanently. Okay. A hard disk or CD or a DVD is an example of this kind of storage. Then we have something called as tertiary storage or optical storage. See, unlike floppy and hard disks, which use electromagnetism to encode data, or optical disk system, they use a laser to read and write data. And these optical disks have very large storage capacity, but they are not as fast as hard disks. So examples of this can be CD or CD-ROMs, DVD, right? Then another component is flash memory. Flash memory are faster than disk storage with up to 4 GB or more of data transferring over universal serial bus, that is USB. It can be transferred over a USB. Then there is a output operation. What is an output? Output is whatever is output from the computer system and the results of processing. It's usually an information. So examples of output are numbers or pictures displayed on a screen, or there can be words printed out on a paper by a printer. Okay. or a music that comes from some loudspeakers. So all these are output. Okay. So any doubts? When coming to IT in communication industry, how information technology is being used in the communication industry, we can say that these days most computers share communications ability, right, which offers an extension capability. So in other words, it extends the power of the computer, like with wired or wireless communication connections. Data may be input from a far off place, right, processed in a remote area and can be stored in several different locations and output in several other places, right? So there are some, how the communication, IT is used in the communication industries can be through mobile communication. That means cellular telephone systems, they must accommodate a large number of users over a large geographical area, right? With limited frequency spectrum, that is limited number of channels. So if a signal or a transmitter, then receiver is used with only a single base station, then sufficient amount of power may not be present. So hence a high power transmitter has to be used in the mobile communication. So however, a high power radio transmitter causes harm to environment, right? Do you agree with this? So mobile communication thus calls for replacing the high power transmitters by low power transmitters by dividing the coverage area into small segments called cells. Okay. So each cells uses a certain number of the available channels and a group of adjacent cells together, and they use all the available channels. Okay. So such a group is called a cluster. And this cluster can repeat itself, and hence the same set of channels can be used again and again. So each cell has a low power transmitter with a coverage area equal to the area of the cell. So this technique is substituting a single high power transmitter by several low power transmitters to support many users in the backbone of the cellular concept. Okay. So if we talk about the present day mobile communication, we can say that, see, radio communication has been used extensively from over a long period of time, as you all know. So initially, the mobile communication was limited between one pair of users on single channel pair. That means the range of mobility was defined by the transmitter power or the type of antenna, and we can say the frequency of operation which was used. So with the increase in the number of users, then accommodating them within the limited available frequency spectrum became a major problem. Right. So to resolve this problem, the concept of cellular communication was evolved. Okay. So the present day cellular communication, what it does is it uses a basic unit called cell. As I said you, each cell consists of small hexagonal area with a small base station located at the center of the cell. Okay. And what they do is they communicate with the user. And to accommodate multiple users, there is something called as time division multiple access, that is TDMA. Then there is a code division, okay, and frequency division, okay, and all these things are used. And if we see today's present day communication, there is modern wireless communication systems, right? So at the initial phase, mobile communication was restricted to certain official users as growth of the cellular concept was very slow. So however, with the development of newer and we can say better technology starting from the 1970s, and with the mobile users now connected to the stations, there has been a remarkable growth in the cellular radio as well. However, the spread of mobile communication was very fast after 1990, right? Okay, we had 1G, that is first generation network. So the first mobile phone system in the market was AMPS. That means it was the first US cellular telephone system. It was deployed in Chicago in the year 1983. Okay, and the main technology of this first generation mobile system was FDMA or analog FM. Then there was second generation network. Okay, it was introduced, digital modulation formats were introduced in this generation with the main technology as TDMA or CDMA. Okay, and the 2G systems introduced three popular TDMA standards, and one popular CDMA standard in the market. I'll tell you what is this TDMA and CDMA. And then there was this 3G, that is the third generation network. Okay. So 3G is the third generation of mobile phone standards and technology, and it is based on the International Telecommunication Union, that is the ITU family of standards under the International Mobile Telecommunication Act of 2000. Okay. Which together with the main industry and other standardization bodies worldwide, what it did is it targeted to implement a global frequency band that would support a single or wireless communication standard for all the countries, okay, globally, to provide the framework for the definition of the 3G mobile systems, okay. Now, of course, we have 4G, and we also had 4G, which provided, IMD, that is advanced specifications, which was laid down by International Telecommunication Unions, okay. And fourth generation networks features where, it provides all IP packet switch network for transmission of voice or data and signals and multimedia also. And it also provided high quality uninterrupted services to any location at any time, okay. They also provide smooth handoffs across heterogeneous network areas. And now we are into 5G. Okay. So there are several transmission protocols in wireless manner to achieve different application-oriented tasks. Okay. Then we have some of these applications, right? Wireless local loop, that is WLL. Then we have Bluetooth. Bluetooth, what it does, it facilitates ad hoc data transmission over short distance from fixed and mobile devices, right? If you switch on a Bluetooth from your mobile and from a another person's mobile device, you can transfer the data, okay. And it also uses a radio technology called frequency hopping spread spectrum, okay. What it does is it chops up the data being sent and it transmits chunks of it upon to different frequencies. So it was Bluetooth was primarily designed for low power consumption with a short range of distance based on low cost transceiver microchips in each device. Okay, so Bluetooth is for transferring data in a short distance without the use of internet. Then we have wireless local area networks. Okay, LAN, and that we have discussed yesterday. Then we had worldwide, microwave access. Then we had Zigbee. Zigbee is the specification for a suite of high-level communication protocols using small or low-power digital radios based on the IEEE standard for wireless personal area networks, that is PANs, such as we have this wireless headphones connecting with cell phones via short-range radio. And then this technology is intended to be simpler and cheaper. And it is also targeted at radio frequencies applications, which require a low data range, okay? And also it also has a long battery life, and it is a very secure networking. You don't have any risk in the networking. And it also operates in the industrial. It's also used by the scientific and medical radio bands also, okay? And in countries such as USA and Australia, it is very common, okay? Then we have Wi-Fi. Wi-Fi is a popular technology that allows an electric device to exchange data or connect to the internet wirelessly using radio waves. Okay. So the Wi-Fi Alliance defines Wi-Fi as any wireless local area network products that are based on the Institute of Electrical and Electronics Engineer, that is the IEEE concept standards. Okay. However, since most modern LANs are based on these standards, the term Wi-Fi is used in general English as a synonym for WLAN. Okay. Then only Wi-Fi products that complete Wi-Fi Alliance, certification testing successfully, they can be termed as Wi-Fi certified trademark. Okay. So see, many devices can use Wi-Fi. For example, personal computers, mobile phones, video games, right? Smartphones, and then we have some digital cameras, tablet computers, and we have digital audio players. All these can be connected to a Wi-Fi. So these can connect to a network resource such as the internet via a wireless network access point. Okay. So such an access point has a range of about 20 meters indoors and a greater range outdoors as well. So Wi-Fi can be less secure than wired connections, such as Ethernet, because an intruder does not need a physical connection, right, to intrude. Web pages that uses SSL are secure but encrypted ones, and internet access can easily be detected by the intruders. So because of this, Wi-Fi has adopted various encryption technologies now. Okay. And if we observe the future trends, see, tremendous changes are taking place in the field of mobile and radio communication, right? So the mobile phone is rapidly turning into a sophisticated device capable of more applications, right? It is also now replacing the personal computers or laptops. And rapid development of the internet with its new services and applications has created fresh challenges for the further development of mobile communication systems. So further enhancements in modulation schemes, will soon increase the internet access rates on the mobile. Okay, from from current, if we observe the current rate, it's 1.8 Mbps. So we can say that it can increase up to 10 Mbps. And then if we observe, Bluetooth is also rapidly becoming a common feature in mobiles for local connections, right? So the mobile communication has provided global connectivity to the users at a very lower cost due to advancements in the technology. Okay. Then we have something called as satellite communication. See, what are satellites? Satellites orbit around the Earth, right? So depending upon the application, these orbits can be circular or elliptical. Okay. So they are responsible for providing the services to an assigned region or an area on the Earth. Okay. And the power and bandwidth of these satellites depend upon the preferred size of the footprint or the complexity of the traffic control or protocol schemes or the cost of ground stations. So a satellite works most efficiently when the transmissions are focused within a desired area. If it's focused for a particular area, okay? And the Earth station should be in a position to control the satellite. So if it drifts from its orbit, it is subjected to drag from the external forces. So when the area is focused, then the emissions don't go outside that designated area, and thus what it does is it minimizes the interference of other systems, right? The disturbance, and this leads to more efficient spectrum usage. So there are some applications of satellites. Okay, satellites can be used for weather forecasting. Okay, certain satellites are specifically designed to monitor the climate conditions of Earth. Okay, and they continuously monitor the assigned areas of Earth and predict the weather conditions of the region. So this is done by taking images of Earth from the satellite, and these images are transferred using assigned radio frequency to the Earth station. Or we can say Earth station, it is a radio station located on the Earth, and it is used for relaying signals from satellites. And these satellites are exceptionally useful in predicting disasters like cyclones, or also they can monitor the changes in the Earth's sea state or ocean color or ice fields, etc. Then satellite can be also used for radio and TV broadcast. Okay. So these dedicated satellites are responsible for making several channels across the globe available for everyone. They are also responsible for broadcasting live matches, then news, then they have this worldwide radio services, right? And these satellites require a 30 to 40 centimeter size dish to make these channels available globally. We have something called as dish TV. Then we have military satellites. These satellites are often used for gathering intelligence, and these are communication satellites used for military purposes, or we can also say it can also be used as a military weapon. And a satellite by itself is neither military nor civil, but it is a kind of payload it carries that enables one to arrive at a decision regarding its military or civilian character, the characteristics of a satellite. So depending upon the usage, we can say that. And there is a navigation satellites which allows for precise localization worldwide. That means with some additional techniques, the precision is in the range of some meters. Okay, so ships or aircraft, what they do is they rely on GPS as an addition to traditional navigation systems. Okay, then many vehicles come with installed GPS receivers, right? For example, we have now all the cars also, they are also equipped with GPS. Our mobile phone is equipped with GPS, right? So this system is also used. Example for fleet management of trucks or for a vehicle location. In case of that, we can track the GPS location and we can track your, mobile phone or vehicle, anything. Then we have a global telephone. See, one of the first application of satellites for communication was the establishment of international telephone, right? So instead of using cables, it was sometimes faster to launch a new satellite. But fiber optic cables are still replacing satellite communications because long distances as fiber optic cable, it's used instead of radio frequency because it's very light and it's hence making the communication much faster. And of course, it is reducing the delay cost due to the amount of distance, right? Because the signal needs to travel before reaching the destination. So in case of satellites, to typically reach a distance approximately, for example, let's say 10,000 kilometers away, the signal needs to travel almost 70,000 kilometers, okay? That is sending data from ground to satellite and again from satellite to another location on Earth. So this causes substantial delay, and thus in turn, it becomes more prominent for users during voice calls, okay? Sometimes you have some disturbance, right? Sometimes there is a delay in response. So this is all because of the, the distance. And then its satellite is also used for connecting remote areas, okay? So due to their geographical location, many places all over the world do not have direct or wide connection to the telephone network, right? Still, there doesn't have, or the internet, because of the current state of the infrastructure of developing countries, they do not have these facilities. So here the satellites provide a complete coverage, and generally there is one satellite always present across a horizon for these type of countries, okay? Then it can also be used for global mobile communication. That means, see, the basic purpose of satellites for mobile communication is to extend the area of coverage. So this is the basic purpose, right? Here, cellular phone systems such as GSM and and if you talk about the other successors, they do not cover all parts of a country. Okay, see, areas that are not covered usually have low population, where sometimes it is too expensive to install a base station also. So with the integration of satellite communication, we can say that mobile phone can switch to satellites, offering worldwide connectivity to a customer, okay, in those particular specialized regions. The satellites cover a certain area on the Earth, right? So this area is termed as a footprint of that satellite, okay? The region which that satellite is covering. So within the footprint, communication with that satellite is possible for mobile users. And these users communicate using a mobile user link that is also called as MUL. And the base stations communicate with satellites, okay? And sometimes it becomes necessary for satellite to create a communication link between users belonging to two different footprints. That means two different regions. So here the satellites send signals to each other, and this is done using inter-satellite link. Then a satellite is also used for GPS, that is global positioning systems. See, as I said, GPS is a space-based satellite navigation system which provides location and time information in all weather conditions, okay? Anywhere on Earth or near the Earth, there is an unobstructed line or site, to 4 or more 5 GPS satellites can be installed there, okay? That means more than one satellites can be installed in that footprint or the region. So the system provides critical capabilities to military, is specially used for military, civil, and commercial uses around the world. Okay. See, earlier, originally, this GPS was meant for a military project, but it is also considered a dual use technology now, meaning it has significant military and civilian applications also. And GPS has become a widely deployed and useful tool for commerce, and it is also used for scientific uses. It's used for tracking and for surveillance, right? For tracking a location. And its GPS is accurate, and it also facilitates everyday activities such as banking. And then we have GPS in mobile phone operations, and even the control of power grids by allowing well synchronized switching, right? You can switch on and switch off the GPS whenever you want. So we can say that Information technology involves the creating, gathering, processing, storing, and delivering of information by a computer, and use of hardware, software services, and the supporting infrastructure to manage and deliver information. And we can say that communication is an integral part of science and is used for exchanging of information between people who are geographically apart. Okay. And each of them, they utilize different set of frequencies for each satellite. They, require utilize different set of frequencies by allocating different number of users and channels. They have revolutionized the communication process by opening up innovative applications, right? And that has also improved the way of living, and it has become an integral part of the society now. Beyond 3G networks, 4G networks, we have 5G networks now, which represents the next complete evolution in wireless communication systems. And then 5G will be able to provide a comprehensive IP solution where voice data and live streaming multimedia can be given to users at higher data rates or higher resolution, okay, than previous generations. Okay, and then satellites should be designed by keeping in mind their usability for short and long-term effects throughout their time. Okay, so this is about hardware, software, and satellites. Then, so what is an internet? We have been discussing about software, hardware, computer, right? Now, to connect this technology, what is an internet? Okay. See, the internet, we can say, is a global network of networks, means computers belonging to individuals and organizations all over the world are connected to the internet for accessing the huge storage of shared information. And internet helps to gather, publish, and distribute this information. So the exponential growth of the traffic that internet carries and the overflowing reservoir of information and data resources makes it, what does it do? It makes it an extremely valuable asset for the modern era. And then many effective communication tools like email, chat services, mailing list, or web conferencing, discussion groups, blogs, RSS feeds, and then we have web conferencing. Then we have social networking sites such as Facebook, okay, Twitter, LinkedIn. These all are used as a means of communication between one-to-one or one-to-many users. So depending upon the need and necessity. And huge information belonging to various aspects of living and working, which includes education, technology, science, marine life. Then it's also used in medicines, and then environment, history, politics, health, defense, everywhere, right? Space and geography. Everything is available on the internet and can be accessed for using in various real-time applications. And the internet can be redefined. It has redefined the business on a global scales, okay? And it has also created a revolution that is impacting all industrial sector. And access to and use of internet is indispensable, right, to every organization due to availability of tremendous information sources. And by incorporating telecommunications, computers and software technologies, perhaps the electronic commerce and multimedia applications, it's changing the way companies do business, right? They have their presence online now. So the internet provides the companies with tremendous opportunities to reach new markets and provide new services. So if we talk about the origin of the internet, in 1969, the Department of Defense of USA started a network called ARPANET, that is Advanced Research Projects Administration Network, with a goal to connect mainframe computers at different universities around the country so that they would be able to communicate using a common language and a common protocol. So ARPANET quickly grew to cover the entire American continent, right? So by early 1970s, ARPANET has spanned the US continent and was extended to some parts of Europe by 1973 and later to the rest of the world. So around 1980, with the advancement of modern communication facilities, National Science Foundation Network was created to facilitate many computers to be linked together. So the original ARPANET eventually grew into the internet by the 1990s. And the internet was based on the concept that there would be multiple independent networks that began with the ARPANET as the pioneering packet switching network, but soon they included packet satellite networks and ground-based, this packet radio networks. So how does the internet function? See, internet is a non-governmental organization, means that is not controlled by the government, where the ultimate authority is the Internet Society. That means it is a voluntary membership organization whose purpose is to promote universal information exchange. And internet's growth compounded with usage of email, which is used, where data is transmitted through the internet and the message reaches the destination located at any part of the world with minutes of transmission. Then if we talk about the growth of internet and emergence of World Wide Web, we can say that the World Wide Web is a repository of information spread all over the world, right? And it's linked together for easy access. And it is made up of documents called pages that combines text, pictures, forms, or we can say sound, animation, and hypertext links into rich communication medium. See, for several users, it is the most exciting aspect of the internet and has accelerated the growth of the internet by giving internet to use easy. It's easy to use and point and click, right? Then it also has a graphical interface. That means users are attracted to the World Wide Web. It's also known as WWW because it's very interactive in nature. And the World Wide Web project was invented by Tim Berners-Lee and Robert Celio while working at CERN, that is an European laboratory for particle physics, to create a systems to handle distributed resources necessary for scientific research, which has grown today to become many, things to millions of users. It is used as a business place now. It can be used as an art gallery, social medium, or broadcast medium, library, community center, or in schools, religious centers. Okay. So the term World Wide Web refers, to the World Wide Web or simply the web. And the World Wide Web consists of all the public websites connected to the internet worldwide, including the client services such as computers and cell phones that access web content. And the World Wide Web is just one of many applications of the internet and computer networks. So originally, the internet served to interconnect laboratories engaged in government research. And since 1994, it has been expanded to several, millions of users, and it's been serving them. And it is used as a multitude of purpose in all parts of the world, right? So in a matter of a very few years, the internet consolidated itself as a very powerful platform that has changed forever the way we do business and the way we communicate. So the internet, as no other communication medium, has given an international, or so you can say a globalized dimension to the world. So internet, we can say, has become the universal source of information for millions of people, whether they're at home or school or at work, right? Wherever they are. And internet is still evolving, and with the recent innovations in the social web and mobile technology, it has changed the way people use it, right? In the social web, people have found a new way to communicate, and mobile technology, on the other hand, it has made possible a much greater reach of the internet, increasing the number of internet users around the globe, right? Then see, the internet, or simply the net as it is often called, stands for interconnected network of networks on a global scale. So it makes possible for computers all over the world to send and receive messages, and it's an interconnected network of several hosts and their networks together, forming a larger network of global magnitude. So it is therefore a global collection of computers and networks that connects millions of people, organizations, military establishments, and governments to a wide range of information sources through a common protocol, okay, that is to communicate. And then the internet is often referred to as the information superhighway, because see, in a sense, it is like a highway that connects you to millions of people and organizations, right? So unlike typical highways that move people and things from one location to another, the internet moves your ideas and information, right, from one place to another. So rather than moving through geographical space, you move through cyberspace, okay? The space of electronic movement of ideas and information is known as cyberspace. Okay, and then if you talk about some internet basics, there is something called as Uniform Resource Locator, or URL. So URL means a uniform way to locate a resource on the internet, right? See, with every file on the internet having a unique address, the URL specifies the address for locating a file. So web browsers use the URL to retrieve a file required from the destination computer. And the actual URL is a set of phone numbers separated by periods. For example, IP address, right? So an example of this would be C 66.71.244.210. This is an example of an IP address. Since these are difficult for humans to use, right? So addresses are represented in an alphanumeric form that is more descriptive and easy to remember. Thus, the URL of a site which can be 66.71.244.210, right? It can also be written as in a www format, okay? www.brau.in. In this format also can be written. And the internet domain name system translates the alphanumerical address to numeric. Okay. So URL, we can say it's an address of a file specified that locates the documents requested through hyperlinks, and similarly may be used to point to a query, image, or a command. And the URL is the global address of documents and other resources on the web. So the internet is a global system of interconnected network of computers that use the standard data, standard internet protocol suite, okay? And the internet offers access to its various resources in data, graphics, sound, software, and other, other forms of data. Then we have something called as HTML. Okay, HTML means hypertext markup language. It's a standard language for creating web pages and other information that can be displayed in a web browser. See what it does? It does, it provides tags that make documents look attractive using graphics or fonts, and also it uses colors to enhance the presentation. So the basic building block of an HTML page is text, okay, which is created using a text editor, while a web browser is used to test the application. The available text editors include Notepad or WordPad for Windows-based systems, while for Mac users, Simple Text is the HTML editor, right? So users can use the HTML in that format. Then we have something called as hyperlink. So a hyperlink is an underlined word or phrase, or sometimes even a graphic image or icon, right? So which has been tagged with a particular HTML command containing the specific address of other location. So user, by placing the arrow and clicking on the hyperlink, will navigate immediately from one specific location to another location within the same document to another document. So, or anywhere on the World Wide Web. So clicking on a hyperlink sometimes generates a sound, or sometimes an image or an animation, okay? So when invoked, hyperlinks provide links to other web documents when you click on that link, and the requests are forwarded to the server, and the server responds with an appropriate response to the client, and the result is displayed on the user screen. So in most internet documents, unexplored hyperlinks will be blue in color, right? Okay. So after the hyperlink has been explored, the color will be changed to purple color. Okay, you can do this exercise. You can, open a web page, and you can also check it by clicking yourself on any hyperlink. Okay, so not only do you get access to information on the internet, you can also access to people. Okay, and there are several services available like email, internet chat, and other cyber rooms. So that all we'll be discussing tomorrow, okay, for tomorrow's class. And that's all for today. Okay, thank you.